بسم الله. We'll share the icon here. I think it's the project I haven't received many names in the line. So please, if you haven't sent me the project team, send it to me اليوم. لا تأخر علينا. طيب, project, I will go over it to explain the main idea, and then there are details that you need to learn yourself by MATLAB and so on. So the project is about basically about implementing a very basic communication system. Didn't fill in here the examples. They have problem indeterminate. Kind of is basically a random process. Random process is a graph. So here we try to learn how to find or design the minimum signal power required to achieve a given bit error probability in digital communication system, and study the effect of the noise power, the noise power, and the quality of a real audio signal. And after we do this, we'll ask you to create an audio file من صوت issue and insert it inside that position. بحيث انك تشوف to add more and more noise if the soft is in place. Yeah, it will be fun, inshallah, if you do that. So we start with the background. We talk about the procedure. So if you understand the background and then follow the procedure, it should be easy. طيب, الفكرة كالتالي. In digital communications, أول شيء كم واحد منكم أخذ في سنة؟ يعني الناس تريزي هاي فيها كذا. يعني أخذها خلصها وما خلصها. أو كم هذا خلصها. لأنه basically you don't need anything from T70 here. What you need is T15. But the T70 at least سهل شيء بس نتكلم عنه. لكن ما في يعني if you don't have T70 even you will not have a problem. بس ما شاء الله نقدر ناخذ T70. طيب, in digital communication system, information is transmitted by sending consecutive pulses. Basically, let's say pulse represents a 1 or 0. The pulse representing 1 is a positive pulse, and the representing 0 is a negative pulse. Okay, so we call this anti-model communication system. Bit 1 is represented by a pulse of square root of EB, which is EB here is the energy per bit, and 0 is represented by the negative pulse. Due to the impairment of the channel, as in the noise, the received signal will be square root of EB, which is the signal that you send. Have a given that you send the pulse 1. Square root of EB, SL will be positive or negative 1, and plus noise. Noise is a random thing that we'll try to understand how does it behave. Okay? So my received signal is some constant multiplied by positive or negative 1 plus a noise. Tamam? طيب. So this basically explains the kilometer. Now the random variable Ni here is a noise sample that is added to the signal, and it's using central link theory. The noise sample is basically modeled as a Gaussian random process. So every noise sample of this is a Gaussian random variable. Okay? هذه الشانل نسميها additive white Gaussian noise. يعني بغض النظر تعرف ايش يعني white. So we'll talk about it when we come to the rate. Chapter 8, we'll talk about the white noise. Okay, so now upon receiving the received signal, how do I detect it? ايش رايكم؟ انا عندي تجيني السيجنال عباره عن positive or negative square root of EB plus noise. النويز هذا zero mean with certain value. تمام؟ الان when I receive a signal, انا ما اعرف ايش اللي يتسجل، ما اعرف انا ارسلت 1 or minus 1. If I send a signal, if I receive a signal, تجيني noise تكون 0.25. How do I detect it? ايش رايكم؟ ما تعرف النويز. النويز نويز، انا ما اعرف. انا اعرف اني يا ارسلت 1 يا ماينس 1. النويز is 0. What do you think? How do I listen? How do you take this signal? 0 mean? Yeah, 0. Right, again. انا جالس ارسل يا بوزيتيف يا نيجاتيف. واضيف عليه نويز. النويز 0. ايش معناها؟ equally likely above 0 or below 0, right? طيب, أنا جتني سيجنال what do I do? أقارنها بإيش؟ عشان أقول أنا أرسلت 1 ولا ماينس 1. صح؟ إذا above 0 أنا most likely I send 1 صح؟ إذا below 0 most likely I send negative 1 isn't it؟ تطلع فوق وتنزل تحت. النويز is 0 mean. On average, النويز has 0 mean. ايش يعني 0 mean؟ On average it is 0. So it will not change the average if you receive signal. It receives signal on average مرة فوق مرة تحت مرة فوق مرة تحت صح؟ The noise is average 0. So most of half of the time you will have larger than 0. The other half of the time you will have less than 0. So in order to detect the signal, إذا هذه أكبر من 0 we detect S as 1. If it is below 0 we detect it as 1. خلاص؟ So now هذه نسميها حاجة اسمها maximum likelihood detector. Again, what does this do? Decide that if the PDF of the received signal given S1 is larger than the PDF of the received signal given -1, and decide 0 otherwise. Right. And the average bit error rate or probability, how do I calculate it? Average bit error probability equals the probability of error given S1 multiplied by probability of S1, which is that, plus the probability of error given S minus 1, multiplied by the probability of S minus 1. When I do that, we are having equal likelihoods. So this is half, this is half. Then I need to calculate the probability of error given S1, but multiplied by half plus the probability of error given S2. And this is the way the transmitter, receiver, and the average probability of error we calculate. Now the performance will depend على noise power. الآن خلينا نقول نرجع هنا. If the variance of the noise here is small, ايش يعني variance is small? It's always around 0. Will you cause many errors? لا صح ولا لا؟ بينما إذا the variance is large معناها there is a lot. So it's around 0, however, it can take large values. So you will see that most of the times, this noise will take the 1 to positive, to the negative part, and the -1 to the positive part. You will have many errors. So the probability of error will depend on the variance of the noise. Well, we'll try to find how does the probability of error depends on the variance of the noise. So the variance of noise is sigma squared, and as the noise power increases, the noise samples become larger on average, and the receiver starts to confuse the signals more, and vice versa. And can be characterized by defining what we call the signal to average signal to noise ratio. Each average signal to noise ratio is EB over signature. The average signal power is EB, the average noise power is signature. هذه نسميها signal to noise ratio. Now, in the remaining, هذه يعني الباك عشان تفهموها إذا فهمتوها, you will at least be able to perform the following procedure, and hopefully you will enjoy it. Signal to noise ratio. السيجنال الآن أنا جالس أرسل إيش؟ EB pulse with an energy EB with an amplitude squared EB, so the energy will be EB, or a negative pulse with the same amplitude with a negative amplitude, which has the same energy. So the average energy is EB. والaverage energy حق النويز is the variance. زي ما حنتكلم بعدين في random process. When we relate the power to the random process. So the signal to noise ratio, ايش يعني signal to noise ratio? The signal energy divided by the noise energy. This is equal to ET on. Okay? So now given this, and I gave you the procedure how to simulate the binary transmission. So what I want you to do is I will show you to derive and simplify the expressions in one. Each of the expressions in one. And decide bit 1 if this PDF is larger than this PDF. And I gave you the signal. I gave you the distribution of this. This is plus minus 1. So given S1, what is R? What is this PDF? What is this PDF? Simplify. Okay, using the background lesson repeatedly. And then derive and simplify expression for the average probability of error. هذا الaverage probability of error اللي أعطيتك إياها. Derive. Find it. Okay? Follow.
PDFs inside pick one or pick two.
أنا أعطيتك السيجنال موديل. أنت find out Gaussian or not. Given S1, I know S1 was 1. إيش هذا عبارة عن إيش؟ إذا هذا 1 What is this signal? What is this thing? ايش الرقم هذا يا جماعه؟ Constant plus Gaussian norm, صح؟ And they gave a distribution 0 mean various signal square. So what is the distribution of this? You know the period. نفس الشيء given minus 1, you know the period. So try to simplify. Again, the probability of error, you need to find the probability of error, derive it, and simplify it. Again, هذه كلها ما لها علاقة بالفيزيبيليتي، هذه أو 350 أو communication. This is all probability theory examples and questions. And then simulate the performance of the anti-border binary communication over AWGN channel using the following steps. أنا أعطيتك الsteps حبة حبة. قلت لك okay, perform the following من B إلى F for every value of the signal translation. أنا أعطيتك إياها بالDB, you need to change it into linear scale. And then you start by generating a random binary sequence with equal ones and zeros. Random binary function في الماتلاب اسمه line. You need to use it to generate equally likely zeros and ones. Basically uniform distribution, and use this uniform distribution to generate equal likely ones and ones. You need to think about how to do it. Using rand, sorry. So generate like with that size 1000 also. And convert into plus minus ones. يعني مثلا ممكن نقول هذا uniform from 0 to 1. إذا أكثر من 0.5 I would say it's 1. إذا below 0.5 I would say it's minus 1. By this you will get equally likely ones and minus ones. Okay? And then add independent Gaussian noise sample to each signal. So basically assume EB equal 1. What you send is this vector. Add it to it a Gaussian noise sample or vector. So assume EB equal 1, then find the corresponding EB, gamma, sigma. So when I give you what is the signal to noise ratio, the value, start by 0 dBs. If EB is 1, what should be sigma square? If sigma square is found, then you can find the rand n. So in Gaussian noise using rand n. مثل rand هذا بس في rand n. And then apply the maximum likelihood with the receiver that you will simplify. اللي في step هذه هنا. Step number 1. And then count the number of number of errors as you transmit every vector, and then keep repeating the form من B إلى F, من B إلى E until you get 100 errors. By this, you will have certain average probability of error for a given SNR. Now change the SNR after that to the next value and repeat the process. You will have another probability for this SNR. Change the SNR until you get a graph showing the probability of error versus SNR. Okay. Now, for a specific probability of error, I take 10 to minus 4. What should be the minimum signal power? Repeat for 10 to minus 3. Okay. And then probably SL here. After that, after you do all this, generate a real audio file, 30 seconds. Then whatever you want. Use the anti-border binary system explained above to convert every sample into binary. And then convert from binary to samples at the receiver. هذا RX means receivers. TX means transmitter. And pass through the AWGN اللي تكلمنا عنها. And then find the values of SNR, values at 1 dB, 5 dB, and 9 dB. Reporting, you need to do it and find the whole report out and so هذه انت الان انا اللي سويناه نحن هنا عباره عن ايش؟ We generated هذه اللي هنا من هنا. We generated random binary sequence, right? Equally likely plus minus 1. بعد كذا ارسلناها على AWGN وحسبنا السيجنال. الان في النكست هنا في السندرين instead of generating do the same thing like instead of generating random ones and zeros, لا انا ابغى ones and zeros come from the audio file. You have an audio file. Audio file عبارة عن ايش؟ when you speak and insert it into MATLAB, it will be samples of certain magnitudes. You need to quantize. You need basically to digitize. Using change it from analog to digital. You will find a analog to digital converter. So your voice will be converted into plus and into stream of zeros and ones. The 0 will be -1. The 1 will be 1. and then insert it here and do this. واضح؟ أيوه. We need to investigate. We need to do some more. We need to it's a project. Now, we like a group of 3 people, so basically we need to do some investigation. The noise is Gaussian noise. So, for example, for this 1,000 vector of data, you need to generate 1,000 vector for the noise using rand n. هذا rand يعطيك uniform distribution, rand n يعطيك normal distribution. But you need to specify mean equals 0 for the rand n, and you need to specify sigma square. Sigma square will depend on the signal translation, which one you use.
So how can I define the sigma square if I want to mix this?
Yeah.
And here's what define the sigma square.
Yeah.
So in fact, it's only finding corresponding what.
هنا ولا وين؟ أنا أكيد يعني سؤال. Signal translation is 0 dB. 0 dB إيش معناها؟ linear إيش معناها؟ 0 dB linear count 1 صح؟ 10 dB 3 dB is 2. So خلينا نقول 3 dB 2. What does 2 mean? And I gave you that EB equal 1. So 2, which is signal translation, equals EB over sigma square. EB is 1. So what is sigma square? 2, right? Sorry, 1 over 2. Sigma square comes here, 2 comes here, it's 1 over 2. Now if I change the signal to noise ratio, if I change the signal to noise ratio from 3 dB to 6 dB, let's have 6 dB. 4, dB equal 1. So the signal to noise ratio equal 1 over sigma square. So what is sigma square? 1 over 4. So for every value for the signal to noise ratio in dB, change into linear and then find the corresponding sigma square. Okay? This sigma square will be the variance that you will put for in the noise, in the Gaussian noise.
And the next sigma square.
For every, yeah, sure. What we are doing, we are trying to plot probability of error versus signal to noise ratio. For signal to noise ratio, outcome 0 dB, you will have to repeat this until you get 100 errors. You will get probability of error. Now, if I change the signal to noise ratio, I need to repeat the same. You get another probability. Changing the signal to noise ratio again, I will get another point. Connecting this point will give me the probability. This is the same. So I think you need to read and think about it. It will sink as you read. One, you need to do some reading from the internet and others, some sources, so that at least you comprehend the phenomenon. And I assume that from one explanation it will not come to your head right away, but should come by after reading. It's a typical commentary, يعني في 70 آخر نتيجة في 70 should be enough. Okay. 70 book should be enough when you after visualization ATD, when you go to the noise analysis, the basic noise analysis of the anti-border signaling, you will find it. If you Google anti-border signaling noise AWGN, you will find it. في جزء من البروجكت to do some simulation, to do some coding, and جزء أكبر منها to do your own reading and investigation, to be able to learn by your own. Okay? يعني طول الكلاس جالسين يعطيكم الآن جزء من الكلاس من البروجكت is you learn yourself and وأنا لكم من الخبرة يعني خبرة مع الشباب في النماذج اللي قالوا they find it fun when they do this. بالذات when you reach to the point of the voice and still add sort. تعرف كيف how to add noise to the voice. How you hear the voice with more noise. تشوف كيف مختلف. When you have 1 dB you hear it noisy and so on. As you increase the number of the dBs or the signal translation, you find it more clear. That will be hopefully this is the
minus 4 dB. The probability of the error itself.
Yeah. And after I plot probability of error, that's the signal translation. For 10 to minus 4, how much signal translation do you guarantee? Okay. Oh.
Another thing. Do they have a fixed value or should I each time record the new?
No, fixed only. For the audio, you will not repeat this again. You will only run it once. Add the noise and listen to it with the noise. Add the noise at certain when it's 1 dB. When the signal translation is 1 dB, hear it after this noise is added. Compare it with 5 dBs, compare it with 10 dBs و 9 dBs. هتلاقي انه هنا هيكون مره واضح، هنا هيكون مره سيء، هنا في النص. واضح؟ لا هي زي ما قلت لك هذه خلينا نقول الفن بارت. Okay, this is the fun part of it. You can add an image if you want. It doesn't matter. هي فكرة انكم how to play with real signals when we do all these analysis and so on. هنا إلى الآن جاف هذا كله. You will get a graph, شيء مميز. No, هنا it's fun. You will start to hear things and play with things. Okay? Links also. Something very good. لكن to hear it enough يعني 30 seconds معلش يعني طب مين كان اللي راح نعم؟ اللاين انا حاطه الى كم؟ 23 اوف ديسمبر هي اخر يوم قبل الفاينلز. So you have enough time. You have long time. Like you need to start. I think قبل الجازة you need to start. You need to read and you need to start. السنة الماضية بصراحة مع الشباب في بعض الدروس اللي يعني خلاص وين ما هو صعب بالمرة. لكن you need to start and try to understand it. Okay. Utilize the education. I don't know what you utilize. I'm not assuming that you work for the education, but I think part of the education should be developed for this. Be careful. But any other questions? Again, I don't assume that you will get everything from this explanation. You need to do your own. هذا كانت عبارة عن just to break the ice between a long file of talk or text and what I need. I hope that we broke the ice. Now you can read more. أي سؤال ثاني؟ تفضل. نعم؟ تفضل. تحت. Part A? Yeah, you need to go. هذه هي the process for every signal translation value. Once you do it, you will get a point of error. Now change the signal translation. Convert what? I mean, في البداية, you need to convert. For 0 dB, what is the corresponding linear and continue. For 2 dBs, what is the corresponding linear and continue. So to get a smooth curve 1 dB. ترى يا شباب كلها حتكون for loop ما هي dB. You will not feel it. Once you do it for 1 point, يبقى عبارة عن for loop. For loop basically SNR equal كذا and the rest is calculated with math. 1 dB the value is 0. Like 1 dB when you take as a difference is not 0. Okay? يعني 1 dB as an absolute value, it's equal to 0. Like when you take a difference, this power level is higher than that power level by 1 dB. This 1 dB is not 0. The absolute value of 1 dB is 0, but not the relative value. طيب other questions now? Okay, wish you all the best. Send me the groups. Send me today is your groups, max and tomorrow. By the way, Thursday we will not have a class because we have 2 exams, and I owe you at least 1 or 2 classes. So we didn't take any class. Thursday we will be in class. So hopefully this will be some questions. Hey. Now let's go back to the video that we started. First time, let's continue. So I'm project you need to start as early as possible because it requires some time for you to comprehend the topic and to work on it. And because of that, the earlier the better. Fine. So last time we concluded our work with examples about the autocorrelation functions. And we said that autocorrelation functions are for White stationary function, random process, the autocorrelation function only depends on the time difference between the samples at which you are calculating the correlation. So it doesn't matter when did you do the calculation of the correlation, today or after 1 hour or so. It matters is I'm looking at x of t and x of t after tau seconds. It doesn't matter where t is, whether it's now 5 minutes from now or 2 minutes from now or 1 hour from now. It matters is how much difference in time between the two samples and comparing together. Okay? So if under this we came up with some properties of the autocorrelation function. We said that the maximum of the autocorrelation function always at 0, which is the average power. And the autocorrelation function usually it's an even function because it doesn't matter where you start. If you start here and then count tau to the right, or if you start here and count tau to the left, it doesn't matter. So it's an even function. And we talked about the other different things. And then we gave several examples. One example, how to use these properties to find, for example, the variance of a random process given the autocorrelation function. So now what we'll do, we'll continue with some examples, and then we'll talk about the cross-correlation function, and then the Gaussian random process. As time allows, hopefully we'll be able to do some of that. So another example is about autocorrelation function. Find the autocorrelation function. Find it. Of y of t, given that x of t is White's station. So we have here x of t multiplied by cosine omega 0 t plus 80. I get y of t. So x of t here, x of t, I know it's autocorrelation function. It's given by e to minus a square root of, absolute value of tau. And y of t equals x of t multiplied by cosine omega 0 t plus theta, where theta here, omega 0 is constant, theta here is random value, uniform random variable with that is uniform between minus pi and pi. So theta here is a random variable between minus pi and pi. And this is a theta. Okay, so now I have a random process multiplied by another random process. Cosine omega 0 t plus theta is another random process. I get a signal. What should we have to do? I say now, number side by the modulation. Well, basically it's an AM modulation, where you multiply the signal, which is your voice, which is a random signal, and multiply it by a random phase carrier. Carrier has a unique frequency. Like it has a random phase, then signal of the base station, if you have ولا فالراديو في AM. الراديو في AM انت جالس تحرك السيارة، signal comes at a random delay. الديلي يتغير مع الوقت طول ما تمشي السيارة من الظهر نحن الرياض. Okay, so this delay is uniform or minus 5. So I have a typical communication system where basically I have a signal that is modulating a random phase carrier, and I get my output signal. Now the question is, find the autocorrelation function of this one, the output signal. Given, and I know the distribution of the phase in the carrier, and I know the autocorrelation function of the original signal, my data. So how to do it? I start with the definition of RYY of t plus tau. And this definition is expected value of y of t plus tau. Now, as usual, we need to substitute for y of t. So what is y of t? X of t multiplied by cosine omega 0 t plus tau. And what is x of t plus tau? Sorry, y of t plus tau is x of t plus tau, right? Multiplied by cosine, the same, but t plus tau. Now this is just math. I multiply together. So what do I get here? I get the expected value of x of t plus tau multiplied by expected value of the cosine. What is this? What do we call this? The first one. The orthogonal function of x multiplied by, I have cosine. Why did I not remove the expectation? يعني يكون عندي cosine أشيل expectation. لكن ليش ما شلت expectation here? Because I have a random thing, right? Data is random. إلى الآن عندي random value. Since I have a random value, I need to keep the expectation. إذا constant, إذا هذه cosine omega 0 plus 5, هذا تصير constant ولا random? Constant. Cosine omega 0 plus 5 is a constant. طيب, so expected value of cosine, I know that it's equal to half cosine the summation, cosine plus cosine the difference. So half expected value of cosine the summation. Now if I have a cosine and I take the expected value, I have a cosine wave. Okay. And I take the expected with random phase, and I take the expected value over the phase. What does this mean? هذا عبارة عن ايش شباب؟ عبارة عن ايش؟ Expect minus the integration of PDF of theta, right? Cosine, whatever inside, right? 2 pi, sorry, not 2 pi. Omega 0. Omega 0 t plus omega 0 tau plus m 2 theta, right? D again 2 omega. Thank you. Okay, so D what? I'm integrating with respect to what? Theta, exactly. Because the expected value is with respect to theta. Limits of the integral from come to come. Minus pi to pi. So now, what is this? Minus infinity to infinity, however, because I have, it's only limited from minus pi to pi. What is the PDF? 1 over 2. Come on. So now 1 over 2 pi. Now, what I'm integrating here? Cosine, this is a constant, 1 over 2 pi gets out. Cosine, whatever, for 1 period. Minus pi to pi is 1 period. So what do you get? It's a sine, right? So, sine from minus pi to pi. What is sine at pi? 0. What is sine at minus pi? So 0 minus 0 is 0. And if you think about it, I'm integrating cosine over 1 period. Like the cosine over 1 period, نص هيكون فوق نص تحت. So they will cancel each other. Okay? So this will give you 0. Okay, so the rest will be, so I have what? I have the Rxx, which is the autocorrelation function of x, multiplied by, what is this part? Is it constant or the random? Constant, so we get out of the expectation. So we have half Rxx of tau cosine omega 0 tau, which is the autocorrelation function of y. Now the kind of White's stationary x. What do you think about y? Is it White's stationary? Does the autocorrelation function of y depend on t? So say y x of t is White's stationary, y of t is constant. Now let's see how does this autocorrelation function look like. Ryy of t, Ryy of tau. In order to understand it, let's plot first of all the autocorrelation function of x. So Rxx of tau. This is tau. What does it look like? It's expected. It's the exponential of minus a absolute value of tau. So it looks like this, right? What is the value at 0? 1. And in decay here, the speed of the decay depends on a. If the a كبيرة, ايش يصير في الاكسبريشن؟ decay faster. If the a صغيرة, decays slower. So A كبيرة A كبيرة معناها ايش؟ معناها the random process changes at faster rate. العلاقة بين ال random process الآن وبعد شوي is smaller than the AC. هنجي بعدين chapter 7 and 8. However, this is how it looks like. Now, if I multiply x of t by cosine, this is the way it will look like. It will be this. It will be the same shape, however multiplied by cosine. يعني تبين كأنها cosine wave. يعني cosine omega 0 tau, نفس frequency of the carrier. However, the shape, the envelope of the autocorrelation function will be the same as the envelope of the autocorrelation function. Any questions about? Now let's talk about cross correlation function. Cross correlation function is a function that talks about two random processes. So it's Rxy of t and t plus 1 tau. So basically, I'm comparing here a random process x of t, x of t. X of t, every time I run the random process, I run the experiment, I will get another function. So if I snap at certain time, t1, I will get a random value. So this is the way it looks like. This is the way it looks like, and so on. So every time I will get, for every t, I will get a random value. Another t, I will get another value. T2, and so on. Now I'm looking at this random process at certain time, x of t, and another random process, y, نفس الشيء لها هكذا many sample functions and so on. However, at t plus tau, after tau. So here the cross correlation function, I'm comparing a random process x at time now and after, and with another random process at tau, at t at time tau. مو مثل الاوتوكورليشن فانكشن I'm comparing random process with itself after a delayed version of it. لا. في the cross correlation I'm comparing random process x with the y, another random process after. So it will be expected value of x of t multiplied by y of t. If x and y are jointly Gaussian, jointly Whiteson stationary, then this will be equal to or function of only. It will not depend on when did I do the measurement. It will depend on how much difference in time between every time I do the measurement. X of t plus tau. إذا t هذه سويت لها shift by 1 hour, هنا shift by 1 hour, still I get the same value of correlation. And if the cross correlation function depends on tau, then we call these two random processes jointly Whiteson stationary. If I have the two random processes with the autocorrelation function equals 0, we call them orthogonal processes. وهذه الاشياء لها يعني الاورثوجوناليتي لها معاني اكثر in communication signal processing. But يعني for here just need to know that. ايش معناه هذا الكلام؟ يعني it will not make sense to you. Now, if the two random processes are statistically independent, we know that the autocorrelation function can be split into the product of the two means. If they are independent or what? Uncorrelated, exactly. Or uncorrelated. If they're independent or uncorrelated, then the autocorrelation function can be split into the product of the two means. Okay? Now, if they are Whiteson stationary, then what does this mean? Is it dependent on time? It will be a number. And if y is Whiteson stationary, will the mean be function of time? No. So both of them will not be a function of time, and you will have this. So the autocorrelation function will be this thing. Okay? So if we have independent or uncorrelated wide stationary, then the cross correlation function will be the product between these and in the another. Okay, Shemam? Now let's talk about some properties of the autocorrelation, the cross correlation function. تذكروا في autocorrelation function احنا قلنا it's an even function. So if I make the measurement now or after tau, it's the same as making the measurement now or before tau. So it's an even function. In the cross correlation function, no. Rxy of minus tau equals Ryx. And this happens because if you substitute here, for example, let's say, for example, Rx, let's say that I write this as Ry, call it as U. So T plus tau is U. Then what will be this? This will be U minus tau, right? The T, sorry. If this is equal to U, then what is T here? What is T equal to? U minus tau, right? So this will be equal to expected value of X of U minus tau, right? Multiplied by expected Y of U, right? So if I write Rxy instead of Ryx, I will get a negative sign. Instead of tau, it will be minus tau. And because of that, we have this. Okay. The second thing, again, we'll not derive any of these. The absolute value of the cross correlation function is always less than or equal the autocorrelation function of x at 0 multiplied by the autocorrelation function of y at 0 and the square root. The autocorrelation function x, maximum, so the absolute value was always less than Rxx of 0. Here, no, it's Rxx of 0, Ryy of 0, and the square. And it's always less than the average of them. If we take Rxx of 0 plus Ryy of 0 and take the average, again, it is this. Okay, the first one we call it geometric mean. Sorry. The second is the arithmetic mean. تعرف الفرق بين الاثنين؟ arithmetic mean لما تجمع خلينا تقسم على الاثنين. هذا arithmetic mean، هذا المين اللي نعرفه. The geometric mean when you look at them as vectors. When you look at them as vectors and you take the average of the two vectors, vector wise. Right, I would like to take this. So next time, shall we continue? I think time is up, or no? Yes. So next time we'll take 2 more examples, and then we'll talk about the Gaussian analysis. Thank you very much, Rob. Again, start working on the project as soon as possible. Send me your group. Thank you very much.